So problem number 5, last problem here, an application problem dealing with applying that 30, 60, 90 triangle. So really it's the same thing. So somehow we're going to use that, you know, if we have the short leg, we can times that by 2 to get the hypotenuse. If we have the hypotenuse, we can divide that by 2 to find the short leg. And then once we know the short leg, that's where it's all based on. Once we know the short leg, we can find the long leg by multiplying that by square root 3, or multiplying that short leg by square root 3. And that will give us the long leg. Okay. And then if to get to the short leg, we can take the long leg and divide by root 3 if we have a radical for the long leg, or it'd be long leg divided by 3 if it's a whole number for the long leg times root 3. Okay, so those are kind of the 4 different formulas that you need. So we're looking at this artisan who makes a pendant, and that pendant is the shape of an equilateral triangle. So that means all 3 of these sides would be the same, right? And then we have a height of going in here that is 18 millimeters. So we have a height. So this is a triangle theorem, right? So where's the triangle at? Do you see the triangle? All right, the triangle is right here. Okay, so we have a triangle. And then what do we know about an equilateral triangle? Actually, we have 2 triangles, right? We have this big one, and then we have that red one that I just made. Okay, so this big one, we know all 3 sides are the same. So that means we all know that all 3 of these angles right here, and right here are the same. So, and we know that all 3 add up to 180. So the 3 sides add up to 180. So if we divide by 3, maybe I shouldn't, then all 3 angles. So I probably shouldn't use an S here. We know all 3 angles. So that means each angle will be 60 degrees. So let me draw it over here. So that means this is 60, and this is 60. Well, if I have another triangle right here, and this is 60, and we see that it's perpendicular by that little symbol, it means 90, what must this one now be? What happened to this 60-degree angle? What happened to just this small one right here, from here to here? That must be 30. So I have a 30, 60, 90 triangle, and I know this is 18. So which side is that? What side is that? And I'm trying to find this side S, right? So this S does not stand for the short side. It just stands for a variable. It just means the length of this pendant, the side of the pendant length. Okay, so where's 18 across from? What angle is 18 across from? Well, it's across from the 60. So that means 18 would be the long side. Why did I write long twice? I don't know. Long side is 18. That's a beautiful 18 too. Okay, and this S, well, what's that across from? Well, that's across from the 90. So this S is actually my hypotenuse. Well, how do I go from the long side to my hypotenuse? I always have to go to the short side. Always have to go to the short, and this is the short. So how do I get to the short? Either by taking my long and dividing by 3 and then timesing by root 3 if it's a whole number, or if it's a root, I just take it and divide by root 3. Well, 18 is a whole number, so to get to my short side, I want to take 18 divided by 3 and then times by root 3. So I'm going to simplify this, and I get 6 over root 3. So my short side equals 6 root 3, and now I want my hypotenuse. Well, to get my hypotenuse, don't I have to just take that and multiply my short leg by 2? So multiply this by 2. I can't times the root 3 by 2 because that's a root. This 2's on the outside, it's a whole number, and so is this 6, so I multiply those together. So 12 root 3, that is my hypotenuse, which stands for S. So this S is, 12 root 3. Okay, and there you go. So this one, you're going to do the same thing. You have the pendant, but this time it is 18 millimeters long. So this side is 18, and you're asked to find what does this height need to be. So what does this height need to be? Right here, this red one. Okay, so you kind of go backwards. You start with this side. Well, what is this side? Is this side the short leg of this triangle? Is it the long leg, or is it the hypotenuse? And so you're trying to find this one right here in green. Okay, all right, that's it for problem number 5 and last problem of this section.